Dear viewers, welcome to the YouTube channel H2O Chemistry. In this video, we are going to learn the topic called extraction of aluminium. The extraction of aluminium involves two important processes. The first process is called Bayer's process. The second process is called Hall's process. So in this video, we are going to see the first process called Bayer's process. Before we learn the Bayer's process, let us understand some facts about aluminium and the ore. Aluminium is the most abundant metal in the earth crust. Aluminium is a highly electropositive metal, that is, it's a reactive metal. So it does not occur in the free state, it occurs in the combined state. So the combined state, you could see, that means the aluminium reacts with air and other elements to form compounds. That is we call combined state. You could see here the bauxite ore Al2O3.2H2O, which is chief ore of aluminium, from which the aluminium is extracted profitably and economically. The other minerals are corundum, Al2O3, feldspar, cryolite, alunite. This alunite ore is available in Punjab area. In Aluminium, all these ores are available. Minerals we call. Out of these minerals, bauxite is considered as chief ore of aluminium. The bauxite is available in India in mainly Karnataka and Madhya Pradesh and other parts of the India. The process is called Bayer's process. The scientist who invented this process is Baeyer. He invented in 1887. The primary process or the objective of this process to convert the bauxite ore into alumina. So what is alumina? Aluminium oxide. So we are going to convert this Al2O3.2H2O to aluminium oxide Al2O3. So this process is used to produce the world requirement alumina. So far till date it is used. It's a very successful process. As I told you earlier, the extraction of aluminium from bauxite involves two important steps. The conversion of bauxite into alumina, which is nothing but Bayer's process. Al2O3.2H2O gives Al2O3. So the conversion of these steps we call Bayer's process. The next process, electrolytic reduction of alumina. When I talk about reduction, we are removing oxygen. So when we remove oxygen from aluminium oxide, we get alumina, which we do electrolytically, which is we call Hall's process. Okay, let us start the Bayer's process. The conversion of bauxite into alumina. The Bayer's process involved four important steps. The first step, the bauxite ore is crushed, washed and dried in the mill and then converted into the pressure vessel. In the pressure vessel, the temperature is maintained in between 170 to 180 degrees centigrade, in which concentrated sodium hydroxide is added. It is called caustic soda. So we are adding chemical. So the concentration of bauxite ore is called Bayer's process. This we do by a method called leaching or chemical method. So in chemical method we used to add a chemical so that the ore is, the required metal is converted into soluble components. The impurities remain insoluble. So in this way we can easily concentrate. That is what we are doing here. In the pressure vessel we add sodium hydroxide, which will precipitate the aluminium as sodium tetrahydroxoaluminate. It's a soluble complex salt. So along with the impurities, when you filter this mixture, the soluble sodium tetrahydroxoaluminate is filtered out as a filtrate. The residue is called red mud, which we can discard easily and properly. The next one. Here I mentioned a word called soluble sodium metaaluminate, but here it forms a complex called sodium tetrahydroxoaluminate. What is a relation between these two? If you closely watch, the word meta indicates removal of water. You could see here, in the hydroxide molecule in the complex, there are 4 hydroxide molecules. That means 4 hydrogen and 4 oxygen. When you remove 2 water molecules from this complex, what do you get? 2 water molecules means 4 hydrogen and 2 oxygen. So when you remove it, there are 2 oxygens when there are 2 oxygens remaining. So you just add with sodium and aluminium. So we get sodium metaaluminate. So from this complex, after removal of water, we get sodium metaaluminate, which is soluble, whereas impurities are insoluble. Right? So the equation, if you see, aluminium oxide plus sodium hydroxide, bauxite is nothing but bauxite, give sodium metaaluminate along with water, which is soluble. So once this mixture is filtered to remove the impurities we call red mud, it is removed properly. The remaining solution is transferred, this soluble sodium metaaluminate is transferred to the precipitator. It is a large tank. In the precipitator, we used to add a lot of water, excess of water we add. So when you add water, what happens? The soluble sodium metaaluminate precipitates as aluminium hydroxide along with sodium hydroxide. So here some aluminium hydroxide, pure aluminium hydroxide, we add to the crystallization process. So as a seed crystals, so to initiate the crystallization process, we add a pure aluminium hydroxide into the precipitator, so that aluminium hydroxide precipitates starts and then it settles down at the bottom. So the equation, if you see, the sodium metaaluminate combines with water molecule to form aluminium hydroxide along with sodium hydroxide. So we want only aluminium hydroxide, so we need to remove this sodium hydroxide. So this mixture is taken into the rotatory kiln. There what happens, we will see. The aluminium hydroxide settled on the bottom of the precipitated tank is removed, and washed is very important to remove the remaining sodium hydroxide, something like caustic soda. Now, in the rotatory kiln, the aluminium hydroxide is heated to around 1000 degrees centigrade for about 1 to 2 days. It's kept. When you do this, the aluminium hydroxide is a very heavy substance, will become a lighter one by losing water molecules. So which forms aluminium oxide, we call alumina. So the aluminium hydroxide, if you heat it, it becomes alumina, we call aluminium hydroxide, along with 3 water molecules. So this will be washed and dried as a fine powder, right? After fine powder, right? After making fine powders of alumina, the alumina is treated into the Hall process. So the alumina is reduced in the Hall's process to produce aluminium electrolytically. That is the next process. I hope this Bayer's process is very easy to understand. If you like this video, subscribe and click the bell button to get the notification instantly. Like this video, share it to your friends. If you have any doubts, comment. Thank you.